If you're still using just certificate-based authentication for your AWS Client VPN, you're one stolen laptop away from a security incident that could cost your company everything. I've seen it happen 3 times this year alone.
Okay, that's terrifying. But wait, I thought certificates were supposed to be secure.
Hey everyone, welcome back to the Network Ninja Cloudcast. I'm your host, and today we're diving into something that trips up even experienced engineers. We're talking AWS Client VPN authentication methods, and trust me, choosing the wrong one can leave your network wide open.
Hey everyone. Yeah, I've been setting up Client VPN for a side project, and honestly, the authentication options confused me. There's like 3 different ways to do it?
Exactly 3. And here's the thing, each one solves a different problem. Let me paint you a picture. Imagine your VPN is a secure building. You need to verify who's walking through that door, right? But how you verify them depends on what you're protecting and who's accessing it.
So it's not just about picking the most secure option?
Not at all. It's about matching the authentication method to your use case. Let's break down all 3. First up, mutual certificate authentication. This is like having a special keycard that both you and the building recognize. Your client has a certificate, the server has a certificate, they verify each other. AWS requires you to import your server certificate to AWS Certificate Manager. And this is important. You can't use ACM's public certificates for this. You need to generate your own certificate using a PKI, typically with EasyRSA or OpenSSL, and import it. It has to be an RSA certificate with a 2048-bit key, and you need to import it in the same region where you're creating your client VPN endpoint.
That sounds pretty secure to me. What's the catch?
The catch is certificate management becomes your problem. You need to track expiration dates, handle revocation if someone leaves the company, and here's the kicker, if someone's laptop gets stolen with that certificate on it, that certificate is valid until you revoke it and update the client VPN endpoint. See, AWS Client VPN uses certificate revocation lists, or CRLs. Just revoking the certificate in your PKI isn't enough. You have to generate an updated CRL and then import it to your client VPN endpoint using the Import Client VPN Client Certificate Revocation List API call. Until you do that, the stolen certificate still works.
Oh wow, so there's an extra step people might miss. And there's no password prompt, no MFA, just the certificate.
Exactly. Now, for small teams or dev environments, mutual TLS works fine. But for enterprise, you want Active Directory integration. This is like adding a security guard who checks your employee badge against the company directory. AWS Client VPN integrates with AWS Directory Service, either AWS Managed Microsoft AD or AD Connector if you're connecting to on-premises Active Directory.
So now users need their AD credentials to connect?
Right, username and password, verified against your directory. The nice thing here is that AWS Directory Service handles all the authentication protocol details internally. You don't need to worry about configuring LATAP ports or exposing anything. You just connect your client VPN endpoint to your directory service, and AWS handles the communication behind the scenes.
That's way cleaner. So when someone leaves the company and you disable their AD account, they lose VPN access?
They lose the ability to make new connections, yes. But here's something important to understand. If someone already has an active VPN session when you disable their account, that session might persist until it times out. Disabling the AD account prevents new authentications, but it doesn't automatically kick off existing connections. If you need to terminate someone's access immediately, you should also use the Terminate Client VPN Connections API or do it through the AWS console to end any active sessions.
Good to know. I would have assumed it was instant.
Common misconception. Now, the third option is SAML-based federated authentication, and this is where it gets really good. Think of SAML like having a trusted third-party vouch for you. Instead of the building verifying your identity directly, you go to a central security office, they confirm who you are, give you a signed token, and the building trusts that token.
So the identity provider does the heavy lifting?
Exactly. You can use Okta, Azure AD, OneLogin, any SAML 2.0 compliant identity provider. When a user connects, they get redirected to your IDP's login page. They authenticate there, potentially with MFA, biometrics, whatever your IDP supports, and then they get a SAML assertion that the VPN endpoint trusts.
Wait, so I could require MFA for VPN access without AWS having to handle MFA directly?
Now you're getting it. Your IDP handles all the authentication complexity. Conditional access policies, risk-based authentication, MFA, all of it. AWS just needs to trust the SAML assertion. Now, setting this up takes a few steps. First, You create a SAML application in your identity provider and configure it specifically for AWS Client VPN. You need to use the correct assertion consumer service URL format that AWS expects. Then you download the IDP metadata, create an IAM SAML identity provider using that metadata, and finally configure your client VPN endpoint with the IAM SAML provider ARN. If you're using the self-service portal, you'll also need to set up a separate self-service SAML provider ARN.
So it's not just a quick IAM configuration. There's setup needed on the IDP side too.
Exactly. The IDP configuration is actually where most people run into trouble. Make sure you follow AWS's documentation for the specific SAML attributes and ACS URL format.
Okay, so what's the most common mistake you see people make with these options?
Two big ones. First, people use mutual certificate authentication alone for production environments with dozens of users. Managing certificates at scale is painful, especially that CRL update process, and you lose the ability to enforce password changes or MFA. Second mistake, they don't realize you can actually combine mutual certificate authentication with SAML federated authentication for defense in depth. When you're configuring your client VPN endpoint, you can select both authentication types together. You get certificate-based device verification plus user identity verification.
So the certificate proves it's a trusted device, and SAML proves it's a trusted user?
Exactly right. The certificate validates the device, SAML validates the human. Even if someone steals credentials, they can't connect without a device that has a valid certificate. Even if someone steals a device, they can't connect without valid user credentials.
Let me make sure I've got this. Mutual certificate authentication is simple but hard to manage at scale, requires you to keep CRLs updated in AWS, and is vulnerable to device theft. Active Directory integration ties into existing identity management and prevents new connections when accounts are disabled, though you might need to manually terminate active sessions. And SAML Federation gives you the most flexibility with MFA, and works with whatever identity provider you're already using, but requires proper setup on both the IDP and AWS side.
Perfect summary. And my pro tip? If you're building anything beyond a proof of concept, start with SAML plus mutual certificates from day one. It's not that much harder to set up, and you'll thank yourself later when security asks about your VPN authentication strategy.
This actually makes the decision way clearer. I was overthinking it.
That's it for today's episode. If this helped clarify VPN authentication for you, smash that like button and subscribe for more cloud networking deep dives.
And if you know someone struggling with client VPN setup, send them this episode.
Thanks for watching the Network Ninja Cloudcast. Go try this in your AWS console, and we'll see you in the next one.